Welcome back, dear students. Laws of motion, part 6. The last part 5, we discussed about the friction, okay, types of frictions and advantages, disadvantages of friction, methods to reduce the friction. Okay, this is all we discussed, and based on that, some numericals also we did. Okay, so another one, next one in this class, we are going to discuss about the pulling, pushing. So for a lawn roller, okay, so to pull is easy or pushing is easy. Which one is easier? Okay, to pull or push. So this topic we have to discuss. Okay, so in this class, so about Neet diagrams. Okay, the concept I'll explain. So if they ask any type of numericals, so you can solve. Okay, using this concept. So let's start the class. Okay, here observe here. So pushing and pulling of a lawn roller, which one is easier? So that is our topic. So first I am taking, okay, pushing I am taking. So lawn roller, okay, so wheel I am showing here. Okay, so for example, this is a lawn roller wheel. Okay, so here the weight of the body acts vertically downward. In the last class, so we observed, so normal reaction is for horizontal surface purpose, okay, vertically upward perpendicular to the plane. For inclined plane purpose, normal reaction is balanced by mg cos theta, okay, and that also perpendicular plane only. Okay, so we discussed already. So if anybody missed that class, so I have given in description part 5 friction. Okay, so you can check after this class. Okay, so you'll get the meaning of normal reaction, okay, for horizontal surfaces purpose and inclined plane purpose also I given, you can check once. Okay, here on a horizontal surface the weight of the body acts vertically downward, that is mg. Normal reaction perpendicular to the plane, so that is vertically upward. And here pushing time, so we are up, okay, so some pushing force we are applying on the body. So what happened that time, so the applied force like acts vertically, so like downward direction it acts. Okay, so the time this force F I am resolving into two rectangular components. One is horizontal component, that is we can take F cos theta, horizontal component I am taking F cos theta, and another one is vertical, okay, another one is vertical, that is F sin theta I am taking. Horizontal F cos theta and vertical F sin theta I am taking. Okay, so here the angle horizontal, so angle is how much, theta I am taking. So it is very clear, the upward forces are equal to downward forces, we know that. Okay, so you can take upward force is what, N is equal to downward forces are what, mg plus F sin theta, both are there. Okay, mg plus F sin theta. Okay, next, so here when the resultant force F, okay, so your frictional force formula we know that. So frictional force formula is what, Fr equal to rolling friction. Rolling friction, frictional force formula is what, Fr equal to mu r into N. Fr equal to what, mu r into N. So here Fr equal to mu r N. So here N value just now we calculated already. So substitute mu r into N value is how much, mg plus F sin theta, mg plus F sin theta. Okay, so Fr equal to frictional force, Fr equal to what, so mu r into mg plus F sin theta. The resultant force, okay, so the pulling force you say, the pulling force you say P1. Okay, so the P1 equal to pulling force, P1 equal to, so the horizontal force F cos theta, okay, against this frictional force, so that is what, Fr. Frictional force is what, Fr. So Fr will substitute P1 equal to F cos theta minus Fr is what, mu r into mg plus F sin theta. Okay, so here P1 equal to F cos theta minus, okay, mg sin theta, okay, minus of mu r into mj plus f sin theta. Open this bracket, f cos theta minus mu r mj minus into plus minus mu r f sin theta. Here p1 equal to f cos theta I am taking f I am taking common, cos theta minus mu r sin theta minus mu r mg. Okay, so this is a equation 1. This one is a equation 1. So f common taken, cos theta minus mu r sin theta minus mu r mg is taken. Okay, so like that only. Okay, equation 1 you say. Next pulling also will compare. Okay, so we'll compare pulling also. So in this, okay, pulling time, the person, okay, is applying force like, okay, upward force. Here also weight of the body acts vertically or downward, that is mg. Normal reaction acts vertically upward, that is n. Okay, so the pulling force is like upward direction. So this pulling force I am resolving into two rectangular components. One is f cos theta. Okay, another one is what? F sin theta. F cos theta with the horizontal, okay, angle is how much? Theta. Horizontal force f cos theta and vertical force is what? F sin theta. Here also we can take, okay, so in the pulling time also we can take, okay, so upward forces are equal to downward forces. Upward forces are what? N plus f sin theta is equal to mg. Here n equal to normal, n equal to what? mg minus f sin theta. Okay, so from frictional force formula, so what is the formula? Frictional force formula directly I am taking Fr equal to what? Mu r n. Substitute the n value, normal reaction. Fr equal to mu r into n value is how much? Mg minus f sin theta. Okay, so here mu r into mg minus f sin theta. So here pushing force, okay, pulling force, how much you are taking? P2, I am saying P2 equal to F cos theta minus frictional force Fr. So that P2 equal to F cos theta minus Fr is how much? Mu r into mg minus F sin theta. So open this bracket, P2 equal to F cos theta minus mu r mg minus into minus plus mu r F sin theta. Okay, so here in this P2 equal to, same here also I am taking F common, here cos theta, okay, plus cos theta plus F sin theta, taking cos theta plus F sin theta minus mu r mg. This is say equation 2. So from equations 1 and 2, okay, so it is very clear that equation 1 and 2, so the pulling a lawn roller is easier than pushing. Okay, so this is the case pulling pushing case. Here another cases. Okay, so now we observe the horizontal bodies. Okay, on a horizontal plane the bodies, the normal reaction we observe. So now vertical plane, for example a body of mass m, okay, so that body is on vertical plane. So to stay on vertical plate, okay, on equilibrium position, what to do? The F amount of force we have to apply. Okay, so the F amount of force we applied on the body. Okay, so that time what happened that time? So this surface also, okay, so whatever the force we are applying F, the surface also exerts some force on the body. Okay, so that is reaction, that is what? N, that only normal reaction. In this equilibrium condition, okay, the weight of the body acts vertically downward, that is mg. and frictional force acts vertically upward. So under the equilibrium position, okay, so we are applying some force to without slip purpose, okay, so that force is F. So that time the body is in equilibrium position. So that time the weight mg equal to, okay, downward force is equal to what? Upward force. So that is frictional force. Mg equal to what? Okay, Fs. So the Fs is what? Okay, so we know that frictional force, static frictional force, Fs equal to what? Mu s n. Okay, I am taking mg equal to mu s n. Here we can observe, so the action reaction, so the N is balanced by resultant force F. So therefore N equal to, we can take F here. So that time what happened? F we can write here instead of N. So that time instead of N we can write force F. So therefore force F equal to, how much force we have to apply on this body without slip purpose? So F equal to what? Mg by mu s. So mu s is what? Coefficient of static friction. Coefficient of static friction. Next case we can observe here. Okay, so what is the case? The on vertical plane before, okay, so we press a body. So now, so one body taken, so the body without slip purpose, with the help of the two hands, so we are pressing like this. The two equal amount of forces we are applying on the body. So for example, the body is there, so I am applying equal amount of force. Okay, so what happened that time? F amount of force, okay, from both the sides we are applying. So that time what happened? The weight of the body acts vertically downward. Here the both the sides frictional forces, okay, so Fs and Fs, okay, both the sides frictional forces I am taking. So total mg, weight of the body is what? Mg. So weight of the body mg equal to what we can take? Mg equal to 2 Fs we can take. So the frictional forces Fs plus Fs, 2 Fs I am taking. So here mg equal to, okay, Fs means what? Mu s n. The coefficient of static friction formula is what? Fs equal to, okay, so mu s into n. Here n is nothing but what? F. Okay, normal reaction and forces are equal. Mg equal to 2 mu s into F. Therefore F equal to what we can take? Mg by 2 mu s. Mg by 2 mu s. So this is, okay, when the body is pressed between the two hands, okay, so that time without slip purpose, okay, so what amount of force we have to apply? Mg by 2 into mu s, where mu s is coefficient of static friction, m is the mass of the body, g is acceleration due to gravity. Based on these cases, how they last problems, okay, so now we'll discuss. You can take question. A horizontal force of 10 newtons is necessary to just hold a block stationary against a wall. The coefficient of friction between the block and the wall is 0.2. The weight of the block is, the weight of the block is they are asking. So it is very clear. Okay, so here just now we did the case. Okay, so to hold the block, okay, so the for applied force they only given, how much given? The applied force is, okay, 10 newtons of force they given. Okay, so then coefficient of friction also given, so they are asking what? Weight of the block, means mg they are asking. Okay, so here the applied force is given, how much given? 10 newtons of force applied, and at the same time coefficient of friction also given, that is 0.2. okay, coefficient of friction also given, 0.2 given. Okay, so then weight they are asking. So just now we did, okay, mg equal to what? Okay, downward force equal to upward force, Fs. Fs is what? Mu s n. Okay, so mg equal to mu s, instead of n, F we can take. Substitute just here mg value we need. Mg equal to what? Mu s into n. Mu s is given 0.2 and F is given how much? 10. So total how much? 1 0, 1 decimal gets cancelled, 2. Okay, weight na, weight units are what? 2 newtons. So which option is correct? Weight of the body 2 newtons. The fourth option is correct. Next question you can take. A person holds a block weighing 2 kilograms between his hands. and kept it from falling down by pressing it with his two hands. If the force exerted by each hand horizontally is 50 newtons, the coefficient of friction between the hand and the block is within the bracket G value also given, that is 10 meter first. You can observe which case the block is holding in two hands. Okay, so how much force is applied here? 50 newtons of force is applied, right? So how much force is applied here? The 50 newtons of the force is applied. Okay, the 50 newtons of the force is applied. What? Okay, mass of the body is how much? 2 kilograms. Okay, so here mu s coefficient of friction they are asking. So what I am taking in this formula? Okay, so mu s I am taking here and f I am sending this side. Okay, so now you can substitute the values. Okay, you can substitute the values in this formula. Mu s equal to what? M is okay 2 kilograms and G they only given 10. Okay, by 2 into F is how much? 50. Okay, so here what we can take? Okay, so this 0 1 0 gets cancelled. Okay, so 2 2 also gets cancelled. 1 by 5 means what? 0.2. Okay, so here the coefficient of friction is how much? 0.2. Which option is correct? So you can check first option is correct. Okay, so like these questions. Okay, so the pulling, pushing, and the vertical plane, that is horizontal and these are vertical plane, to hold the bodies in equilibrium or to slide the bodies on vertical plane. So what are the cases we observed? Another sum you can observe on the screen. Okay, an eraser weighing 2 newtons is pressed against the block, blackboard, with a force of 5 newtons. If the coefficient of friction is 0.4, how much force parallel to the blackboard is required to slide the eraser upward? The two cases we observed before. So with pressing one hand, so to equilibrium purpose, so what amount of force is required, or coefficient of friction is how much we required. So we observed, and two cases within two hands to hold the body without slipping, so that also we observed how much force is required or how much coefficient of friction is required we observed. But in this case so when the force is applied on a body, so the body of weight also they given, so to slide up or down purpose, so how much required force, how much force is required they are asking. So we can see the applied force is given. How much given here? Applied force in this case, so they given here 5 newtons of the applied force is given, and weight of the body they only given how much? Given 2 newtons, and coefficient of friction also given 0.4 they given. To erase the eraser, to slide the eraser, so how much force is required they are asking. The required force is equal to, so what we can take? The weight of the body plus so the weight of the body plus, so general as it is, the frictional force Fs we can take. So here required force is equal to, so what we can take here? W plus Fs is what? Mu s into n. So substitute the values. W is how much? The weight is given 2 newtons plus mu s is how much? 0.4 into the normal reaction just now we discussed is equal to the force only. So that time how much here? 5 newtons. That equal to 2 plus 4 5 is 20, here decimal is there 2. So 2 plus 2 is how much? 4. The 4 newtons force is required to slide the body. 4 newtons is required. So which option is correct from this? The third option is correct. So we can see the third option is correct. So here we observed So in the previous and these friction parts we observed, the previous case we discussed about the friction, types of friction, methods to reduce the friction, okay, and just numericals also, some numericals also we observed. In this case, pulling, pushing and sliding bodies, okay, in vertical plane, to hold the vertical plane with one hand, with two hands, and slide the body on vertical plane we observed. Okay, next part, most important part is there. Okay, so that is inclined plane, smooth inclined plane, rough inclined planes. Okay, so here the time periods, okay, on smooth inclined plane how much to slide down, okay, slide up purpose how much, and rough inclined plane also sliding down, sliding up purpose how much. Okay, same inclination angle sliding down. Okay, so on the once smooth surface and once rough surface, so how much time it will take, one of the okay time period they'll give, another time period they'll ask. Okay, so sliding up, sliding down. Okay, so the time velocities, the resultant forces. Okay, so all kind of numericals they'll ask. If you observe the previous Neet, Eamcet or JE, so this type of questions, okay, number of times they asked. The next class detailedly will discuss along with the, okay, numericals, okay, with Neat diagrams we'll discuss in the next class. Thank you for watching.